In this video, I'm going to walk through the second lab available in the Cisco CCNA lab guide, which is a free lab guide you can download from Flackbox.com. This is the second lab listed in the PDF, so let's get started. This will cover Cisco device functions, and it says this lab explores the MAC address table on Cisco iOS switches and routing table on routers. So let's get started. We've loaded up the configuration. Step 1, log into routers 1 to 4 and verify which interface is configured on the 10.10.10.0 network. So we'll start with router 1. We're going to pull this open a little bit and let's get started here. All right, and we got to go into privilege exec mode, and to see the interfaces, you just type in show IP interface brief. You can abbreviate it that way. And so we've got gigabit Ethernet 00 on router 1, which is here, with the address of 10.10.10.1. So that's there. I labeled it. Okay, let's go to router 2 and go to the command line, and we're going to do the same thing. Enable show IP interface brief, and you see gigabit Ethernet 00 as 10.10.10.2, and that's this one, and I've labeled that one. Let's go to router 3. Let's pull the command line. Enable show IP interface brief. Let's see, gigabit Ethernet 01 on router 3, which is here, is 10.10.10.10.3, got it. And then router 4, pull the command line and enable show IP interface brief, and gigabit Ethernet 00, which is that, has 10.10.10.4. All right, so we verified the interfaces and the IP addresses that go, and I wrote those down so we can reference them. So it says R1, 2, and 4, 1, 2, and 4 are using gigabit Ethernet 00, 00, 00, and 00, and R3 is using gigabit Ethernet 01 for the 10.10.10.0 network. Now it's asking us to note down the MAC addresses of these interfaces. So let's go back to router 1, for example, and we'll pull that open a little bit. And we're going to do the show interface command, and it's for gigabit Ethernet, and I'm just hitting the tab key to fill that in, 00. And when you do that, we'll scroll up a little bit. So here's our command, show interfaces, gigabit Ethernet 00. You can see the MAC addresses right here. Okay, and it also say BIA, which just means burned in address. And so on router 1, interface 00, the MAC address starts with 0090, and I wrote that down. And then router 2, let's do the same thing, and we're going to pull this over here so we can view it. And we're going to do the show interfaces, gigabit Ethernet 00, and it shows that its burned in address or MAC address, it starts with 0060, and that's router 2 for interface 00. Let's go to router 3, do the same, show interface gigabit Ethernet, and router 3 was 01. And we scroll up a little bit and we see its MAC address starts with 001. And then finally router 4. And we're going to do the same. Show interfaces fast, not fast Ethernet, gigabit Ethernet. And router 4 was 00. And if we scroll up here, we'll see the MAC address is 00D0. It starts with 00D0. So I noted the MAC addresses of the interfaces. It says verify connectivity between the routers by pinging R2, 3, and 4 from R1. So let's do that. We'll pull open our router 1, hit Q, and packet tracer. So we're going to ping router 2 first, which is 10.10.10.2. So we're going to ping 10.10.10.2, and we'll see what it does there. So we got success rate of 80%. The first, when you see the dot or the period, that is an unsuccessful response. That's probably from an ARP request. And then when you see the exclamation points, those are successful responses. So router 1 is able to ping router 2. Let's see if it can ping router 3. So we're just going to use our up arrow to pull up the previous command, which is ping. And all we have to do to ping, we're going to ping 10.10.3, which is router 3. And let's see what we have there. And again, we have a success rate of 80%. The first one's going to be an ARP. And then let's do it one last time for router 4, which is 10.10.10.4. And we should have the same thing going on. And we do. So we're good there. All right. So we verified connectivity between the routers by pinging our 2, 3, and 4 from router 1. Now it wants us to ping router 3 and 4 from router 2. So let's go to router 2. Let's ping router 3, which is here. Hit Q. And then we're going to do a ping 10.10.10.3, which is router 3. Let me move that out of the way. And let's see what kind of response we get. Yep, we're successful. And it wants us to ping router 4 from router 2 as well. So router 4, we're going to use the up arrow just to pull back up the previous command. Just going to change the 3 to a 4 because that's router 4, 10.10.10.4. And again, we have a successful ping. So that worked. Now it's asking us to view the dynamically learned MAC addresses on switch 1, which is here, and verify that the router's MAC addresses are reachable via the expected ports. Ignore any other MAC addresses in the table. So to do that, you just go to switch 1 and you go to the command line. Okay, and to first go into privilege exec mode, and then you need to show MAC address table. I just tabbed to finish that, and then dynamic. Okay, and this will show us the MAC addresses. And so you have from fast Ethernet 024, which is this one on the switch, this interface on the switch, it's showing 001, and 001 we know is from R3. I have it as R3. That's not right. So let's look at that again. So let's take a look at the other one. I thought 001 was R3. Let's look at the R3 MAC address. It starts with 001. Oh, I see what's going on. This needs to be, I looked at the wrong interface. So that's correct. I just had to move the label over. This is fast Ethernet 024 on switch 1. So on this interface, it's saying there's a MAC address. It knows of a MAC address of 0001, which is router 3, which is down here, which makes sense. So it's over this way. The next one we see is 000C, which was not in our list of routers. The next one we see is 0060, which should be router 2. So that should be out fast Ethernet 02. I'll move this label over a little bit. And it is. The next one we see is 0090, and that should be router 1. I'm looking at my notes here. And that should be out fast Ethernet 01, which it is on the switch. And then finally we have 00D0, which should be router 4. And that should be out let's see, that one was 00D0. That's also out at fast Ethernet 024, which makes sense because it's over here. So this interface knows of these two. It knows it's connected through this interface to these two. So what is the 00C on the same one? Well, my guess is the switch. So let's pull up the switch number 2. Let's go to the command line. Let's hit enter. Let's get into privilege exec mode. And then we're going to do the show MAC address table dynamic. No, wrong one. I need to show. I'm on switch 2, and so I need to show the interface 024. Oop. Show made a mistake. Interfaces, and that's fast Ethernet 024 on switch 2, and that has a MAC address starting in 000C, which coincides with what we saw over here. 00C is out, it's 24. They're both, can be confusing, they're both 024. All right, so we did that. We viewed the dynamically learned MAC addresses on switch 1. We verified the router's MAC addresses are reachable via the expected ports. That's done. We didn't actually ignore the other MAC address in the table. I looked it up. All right, so let's repeat the same process on switch 2. And we're going to pull it up and hit Q in Packet Tracer. And then we're going to do the show MAC address. Hit Tab to finish that out. Dynamic. Okay. And for switch 2, it shows 001 out interface FAO3, which is here, and 001 should be router 3, which it is. And it shows 00B, which is not one of our routers, so that's probably this switch. 0060, which should be router 2, so that should be out FAO 024. Yes, it is. Then we have 0090, which is router 1 over here, and that should also be out FAO 24, and it is. And then we have 00D0, which is router 4, which should be out fast Ethernet 04, which it is. Okay, that's done. Now it wants us to clear the dynamic MAC address table on switch 1. We'll go there, and the command for that is, let me get over here, clear MAC address table dynamic, and hit enter. Okay, and it's saying show the dynamic MAC address table on switch 1. Do you see any MAC addresses? So let's do that. So we're going to do the show MAC address table dynamic. And right now we don't see any because we just issued this command, clear MAC address table dynamic. So it wiped it out. And it would be, it'll repopulate that MAC address table with any kind of traffic that comes through. Okay, but that's all it asks us, show the MAC address table. Why there's nothing there? Because we cleared it, that's why. And it says devices in a real-world network tend to be chatty and send traffic frequently. This causes the MAC address table to update. You may see less entries in Packet Tracer. And that's the last part for the switches. Let's move to examining a router table. So view the routing table on R1, which is here. And it wants to know what routes are present and why. So to do that, the command is show IP route. And let's pull this open a little bit and we'll discuss that. All right. And after you issue the show IP route command, it'll show you the codes. So for example, local, connected, static. Right now, this is router 1 in its routing table. It has the 10.10.10.0 network, which is this one, top one here, this network between these two interfaces. It's a /24. And it is directly connected. So we didn't have to statically put that route in the table. It automatically learned it because once you configured 10.10.10.1 as the interface on gigabit interface 00, it'll automatically add that network. And then also it shows the local, which is 10.10.10.1, which is the actual interface itself with a /32. So the locals will always show a /32 regardless of how what subnet you used for the actual network. So 10.10.10.0 is a /24 network, but on the routing table under the local, it's going to show it as a /32, and that's for the specific interface of .1. Okay, we've done that. We talked about why. Okay, so it says the router has a connected route for the 10.10.10.0 network and a local route for 10.10.10.1. These routes were automatically created when the IP address 10.10.10.1 was configured on interface gigabit Ethernet 00. So anytime you have a directly connected network from a device and both sides are active, and in other words, both interfaces are up and communicating, it'll automatically configure that it'll automatically add that network to its routing table, the router will. So now it's saying configure IP address 10.10.20.1/24 on interface gigabit Ethernet 01. So that's over here. That's gigabit Ethernet 01. You can see it's down. So we're going to go ahead and pull that open. And we got to go into global configuration mode. So conf T gets us the command to get there. And then we're going to go and we need to go into interface configuration mode. So interface gigabit Ethernet, and we're going to work on 01. And we need to assign an address of 10.10.20.1 with a /24. And the command for that is IP address followed by 10.10.20.1 with a subnet mask of 255.255.5.0, and then issue the no shutdown command, or you could just type no shut, and you'll see now that it's turned green, and the orange dot is spanning tree. Because spanning tree is not going to allow both of these. Spanning tree basically stops you from having network storms from continuous loops. So that's what the little orange thing is, but this isn't going to cover spanning tree. That's going to be for later. So we have configured the address 10.10.21 on this interface, and what routes are in the routing table now. So let's go back here and let's drop down to privilege exec mode and show the routing tables. So show IP route, and we'll open this up a little bit. And router 1 has 10.10.10.0, which is this network up here. The top one is directly connected. It's also got 10.10.20.0, which is the second one down here, is directly connected. And then the local route is 10.10.1, which is this interface, and 10.20.1, which is this interface. And again, local routes are always going to show a /32 regardless of what this actual subnet, how the subnet was configured. Okay, so we looked at the routing tables. It says the router has routes for both interfaces. It can route traffic between hosts on the 10.10.10.0 and 10.10.20.0 networks. Okay, so now it's saying configure a static route to 10.10.30.0/24 with a next hop address of 10.10.10.2. So the next hop is 10.10.10.2, which would be up here at gigabit 00 on router 2. And if we're configuring a route to the network 10.10.30.0, well, that's not even in our topology, so that must be out another interface on router 2. So that's not even showing on our display, but we can still do it. So let's pull this up and go into global configuration mode. Conf T, and then we're going to designate a static route. To set up a static route, which is basically just telling router 1 that this other network that we don't see over here, and it doesn't see because it's not directly connected, we're telling it that it exists and how to get there. Okay, so that's easy enough. And to do that, we just enter the command IP route followed by the network address, which is 10.10.30.0. You give it a subnet mask of 255.255.255.0 because it said it was a /24. And then you give it the next hop address. And the next hop address is going to be what is the next interface that it needs to send packets to get to that network. Well, the next interface, if that network is over here on the other side of R2, connected to R2, or not, I mean, just it's on the other side of R2, we know the next hop has got to be 10.10.10.2. So let's enter that in, 10.10.10.2. You hit enter, and it is configured. All right, so now it's saying what routes are in the routing table. So we're going to do a do show IP route. And the reason we issued the do command is show commands are run in privilege exec mode, not global configuration mode. But a do command will override that and allow you to view it. So do is super handy. All right, so let's look at the routing table. So now router 1 is directly connected, knows it's directly connected to 10.10.10.0, which is this network. It knows it's directly connected to 10.10.10.20.0, which is this one down here. It also now is aware of 10.10.30.0, which we've decided is somewhere on the other side of router 2. And it knows to get there, it has to use the next hop of 10.10.10.2, which is this interface on router 2. All right, so we looked at what routes are in the routing table. And it says the router has routes to its locally connected networks, and also 10.10.30/24, which is available via the next hop of 10.10.10.2. And that's the end of that lab. That one was quick and easy. Still a cool little lab, so I hope you enjoyed that, and I will see you in the next video.